Hi students, welcome to chemistry online. See, in previous class we discussed about classification of elements based on electronic configuration. Yes means noble gases, next transition elements, next representative elements we discussed. Next fourth type we are going to discuss inner transition elements. Inner transition elements. Inner transition elements. Okay, see, points wise we may discuss. First point, the elements belongs to second B group. The elements belongs to second B group. Second B or third B. Third B or third group. Third B or third group elements. Third B or third group elements are called inner transition elements. Why? Because if you take sixth period, after lanthanum 14 elements are called lanthanides. Seventh period, after actinium 14 elements are called actinides. So lanthanides 14 and actinides 14 also present in third B only, which is a first group in the D block. Okay, and then general electronic configuration is N minus 2 F 1 to 14 N minus 1 D 0 to 1 NS 2. General electronic configuration is like this. Okay, means N is the ultimate shell, N minus 1 is the penultimate shell, N minus 2 is the anti-penultimate shell. Means in inner transition elements, 3 subshells are partially filled. 3 subshells are partially filled. Okay, next, so they have high melting points. High melting points. Okay, next, they form colored compounds. They form colored compounds. Next, they form magnetic, means they form Li is not they show variable oxidation states, and they form colored compounds. After that they show variable oxidation states. They show variable oxidation states. Okay, variable oxidation states. And then they show paramagnetism. Then the elements after uranium after uranium are called transuranic elements. Transuranic elements or synthetic elements or synthetic transuranic elements or synthetic elements. So this is briefly about inner transition elements. So third B group or third group, this is IUPAC naming, it is a general naming. Third B or third group elements are called inner transition elements. General electronic configuration is like this. They have high melting points, they form colored compounds due to presence of unpaired electrons or partially filled electrons in D and F. Then they show variable oxidation states. Oxidation states means the charge present on the atom in the molecule is called variable oxidation states. Magnetism means we are going to discuss in second year. Okay, so the elements of uranium atomic number is 92, which is placed in actinides. So after uranium, so the elements after uranium are called transuranic elements or synthetic elements. Okay, this is briefly about inner transition elements. Then you have to know one more important topic we are going to discuss, that is nothing but periodicity. What is periodicity means? If you take periodic table which having vertical columns and horizontal rows, vertical columns are called groups, horizontal rows are called periods. Some properties like physical properties, chemical properties, they may be changed at regular intervals. The properties, the repetition of the properties in the periodic table at regular intervals are called periodicity. The phenomenon is called periodicity. The properties are called periodic properties. So the repetition of the elements, the properties of repetition of elements at regular intervals in the periodic table, that is nothing but periodicity. Now you have to know periodic properties. So how many periodic properties we have means many. So some main we are going to discuss. The first one is nothing but atomic radius. It is AR. So first periodic property is atomic radius. And second one is ionization enthalpy. It is nothing but IP. Third one is electron gain enthalpy. Electron gain enthalpy or electron affinity. It is EA. Next, fourth one, electronegativity. Electronegativity. It is En. Okay. Next, fifth one, nature of oxides. Nature of oxides. These are periodic properties. Okay. So this is nothing but periodicity. These are periodic properties. So what is periodicity means? The properties of elements are repeated at regular intervals in the periodic table. So for example, if you take first period only 2 elements, and next period 8 elements, in next period 18, next 32, next 23, like that. 2, 8, 8, 18, like that repeating now. So that particular repetition is at regular intervals. So one period after one period, one period after one period. The type of phenomenon is called periodicity. The properties are called periodic properties. Now we are going to discuss about atomic radius. The first periodic property is nothing but atomic radius. Okay. Atomic radius. What is atomic radius means? The distance between the nucleus to electron present in the outermost orbit is called atomic radius. For example, if you take atom is a hard sphere, so it is the atom which is a hard sphere. It is nothing but a nucleus. It is a nucleus. It is nucleus. It is a electron present in the outermost orbit or valency orbit. Valency orbit. This is the nucleus and it is the electron present in the valency orbit. Now the distance is nothing but the distance is called atomic radius. It is nothing but atomic radius. So atomic radius means the distance between the nucleus to valency shell of an atom, electron present in the valency shell of an atom is called atomic radius. So it is nothing but a atom. It is nothing but a atom. It is a atom. Okay. Then atomic radius is many types. So types of atomic radius we are going to discuss. The first one, crystal radius. Crystal radius or metallic radius. Crystal radius or metallic radius. See here, what is the crystal radius or metallic radius means? I am taking this radius is in the metal atoms. The radius is measured in metal atoms. In metal atoms. Example, sodium. Example, sodium. Here I am taking two metal atoms which are adjacent side, This is the one sodium metal atom and it is the one sodium metal atom. It is the nucleus and it is the nucleus. It is called A and it is called B. That is a nucleus. It is a internuclear distance. AB is the internuclear distance of the two sodium atoms. And then it is a C. So AB equal to internuclear distance. Okay, that is nothing but 372 picometers. Okay, then half of the internuclear distance is called crystal radius of sodium. Then AC equal to BC equal to AB by 2. Okay, AC equal to BC equal to AB by 2. This is equal to metallic radius of sodium. Radius of this is metallic radius of sodium. Okay, so then AC equal to 372 by 2. Then 2 ones are 2 18s are and 2 6 are. This is picometers. This is AC, metallic radius of sodium. AC equal to 372 by 2, that is 186. So what I mean to say, crystal radius means the radius measured in metal atoms. So measured in metal atoms. Okay, so AB is the internuclear distance. The half of the internuclear distance is nothing but AC. AC equal to BC, that is equal to AB by 2, that is nothing but metallic radius of sodium. Stand. Then stand means understand. Then you have to know covalent radius. You have to know. Then second one, B, is covalent radius. Okay, so it is measured in non-metal atoms. So covalent radius is our non-metallic radius. It is measured in measured in non-metals. It is measured in non-metals. Example, Cl2, like this. So here I am taking two covalently bonded atoms. These are adjacent side. These are adjacent side. Okay, here I am taking covalently bonded atoms. So here It is one chlorine. It is one chlorine. It is the nucleus. It is a Cl and it is a Cl. Then it is nucleus of chlorine A and it is nucleus of chlorine B. So these are covalently bonded atoms. Covalently bonded atoms. You have to covalently bonded atoms. So here it is nothing but internuclear distance. It is a internuclear distance. Then half of the internuclear distance, it is nothing but a C. So AB equal to internuclear distance, AB equal to internuclear distance of two chlorine atoms. Then AB by 2 equal to AC, that is equal to BC, that is covalent radius of chlorine, equal to covalent radius, equal to covalent radius, covalent radius of chlorine. Okay. So here this is next, this is equal to internuclear distance is equal to 188, what is this, 198 picometers. Then AC equal to 198 by 2, this is equal to 99, 2 nines are 99 picometers. This is nothing but a covalent radius. It is nothing but a crystal radius. It is nothing but a atomic radius. Okay. And then you have to know variation of atomic radius in period and a group. Very important. Next, variation of atomic radius. Okay. Variation means a change, how atomic radius changes in period and a group. Then first, variation of atomic radius in period I am taking. Okay, in period. Periods we move from left to right. Okay. If we move from left to right, if we move from left to right, atomic radius decreases. Atomic radius decreases. In period, if we move from left to right, atomic radius decreases. Why atomic radius decreases in periods means due to entering of electron in same subshell or same orbital. Okay. So 1s, next 2s, next like this. So first electron enters into 1s means next electrons also enters into 1s. After filling that, then that is go for next orbital. Here in period, if we move from left to right, so atomic radius decreases due to electron enters into same subshell. Next, in group, okay, in group. So vertical columns are called groups. In groups we move from top to bottom. See, if we move from top to bottom, atomic radius increases. Atomic radius increases because electron enters into different subshells. Electron enters into different subshells. Okay, so this is the way. Okay, then it is variation of atomic radius in periods and in groups. So this is briefly atomic radius. So one more type of radius is there, van der Waals radius, that is not given. So that is for objective type. This is for first atomic radius. So what is periodicity and what are periodic properties? It is very important question. How periodic properties trend in groups and periods, that is very important question. In that we discussed about here atomic radius. Atomic radius means the distance between the nucleus to electron present in the outermost orbit is called atomic radius. Atomic radius is many types: crystal radius, which is in metal atoms; covalent radius, which is in non-metal atoms. So which radius is higher than means note. Here you have to a note. So here it is a crystal radius, it is a metallic radius. Crystal radius is greater than covalent radius. This is a crystal. This is a crystal. This is a covalent radius. Okay, crystal radius is greater than covalent radius. This is briefly about atomic radius. So this is today's class. So going to leave.